Okay, it's recording now. Okay. Okay, so is my screen visible? Am I audible?
Yes.
Okay. Well, the first problem about reverse vowels of a string, it says that you are given a string as an input and you just have to reverse the vowels. So vowels are A, E, I, O, U, and it also says in the notes, it does not include the letter Y. I don't think Y is a vowel as for me, but maybe I'm wrong. So I'm just looking for like the problem statement where it says, the example, if it is hello, so you just need to swap the E and O, right? So the answer would be here like HOLLE, right? And the second example is about the lead code, wherein you can actually, there are two E's and one O and one E. So if you just swap both of them, the first E gets swapped with the last E, so they don't change, but the second E gets swapped with the O, and therefore it becomes LEOTCEDE. Okay. So is the problem statement clear? If any doubts in that, it's very straightforward though. Hello guys, if anyone has any approaches how to do this.
Yeah, so I was thinking to use a two-pointer approach. It would be O of n itself, and we don't need any extra stage. We will put a left pointer on a leftmost side and a right pointer on the rightmost side, uh, and make a condition like left should be less than right, and keep swapping the left and right if both these two are vowels actually.
Good, yeah. I think I also did the same way, so that was a good approach. Yeah, so you're saying that we set two pointers, like one at the right side and one on the left side, right? And then we iterate through whole string, and whenever we find a vowel, if we don't find a vowel on the left side, we just move the left pointer. If we don't find a vowel on the right side, we move the right pointer, and then if we find both of them, we swap, and then we move the left and right pointer. Is that what you're saying?
Yeah.
Okay, that was a good solution. Yeah. And so do you want to share your screen to show a solution, or how is it?
Sorry, actually, I'm in between something, so I can't share the
Oh, no
screen.
problem. Okay. So you're okay, right? What I said, I'll just share my screen, my solution. And if you find any changes or if you want to have anything different, so just let me know. So here I'm actually in C++. The entry function is reverse vowels. The input parameter is string and output is string. So as he said, I forgot your name. So who was talking, by the way?
Yeah, Nitesh.
Sitesh. Sorry,
Nitesh, yeah.
Nitesh. Okay. So as he was saying, it's like we set the left pointer to the 0 position and the right pointer to the last position, n-1, because n is the size of the string here. And then I just do an iteration over here. I find if the vowels, I just go and look for each A, E, I, O, U in the upper cases and E, I, O, U in the lower cases. And if I don't find them, first I just increment the left pointer. I go for that in the right pointer. If I don't find it, decrement the right pointer. If I find, I just swap it and then return the string. As simple as that. And you said it is going to be O of n, right, for the time complexity.
Yeah.
Okay. And what about the space complexity?
It's O of one.
Okay, it's a constant space, right? Yeah. Okay. So I also find that is correct. If anyone has any doubts on that, anything, so do you want to move on the second one or any suggestions?
Yeah, this is good, Santosh.
Okay.
Yeah.
So let's move to the second one.
Yeah.
Okay. Okay, the second one, the linked list cycle 2. Okay, so here what it says is given a linked list, what we have to do is we have to return the node where the cycle begins. So we are given a sort of a cycle, linked list which is cycle, and yeah, it might be a cycle or it might not be. So we need to find if it is a cycle where the nodes connect. Okay, so if you see the example one, it will be more clear. Here it has a linked list where it starts from 3 2 0 -4, and the -4th node actually goes and connects the second node. Okay, and it might also be like, it is a complete circular linked list, or it might not be a linked list at all. Sorry, not a circular at all. So in this case, you just need to uh, return null, and or else you have to return the node where you intersect. Okay, I think this is also a very popular problem. So is the problem statement clear, or anything you guys want to add in this if I miss something?
Yeah, this is clear. This is similar to linked list cycle, but there is one variation in this. Like they gave the position. That's the only difference from the normal linked list cycle and this one. So this is clear. Yeah.
Okay. Yeah, the position, yeah, but actually if I look at the function, entry function, it doesn't say anything about the position, but I think what do you say, the parser actually might be doing that, because I think the test case may be like this, the position one and the linked list.
Yeah.
Yeah. Okay. So do someone has anything want to actually take this, or how do you want to, anyone want to have has any approach, or how could it go, at least talk about it?
Yeah, I can talk about it.
Sure.
Give me 1 minute, okay?
Okay.
I solved it long back. Like
No problem.
yeah, I'm just searching the. Okay. Um, you want me to share the screen?
Sure, I'll just unshare it for now.
Okay.
Yeah, there is someone. Okay, yeah, okay, no problem, good. So you can share the screen now.
I don't have the option to share the screen.
You can actually look at the lower portion of the screen where it says share screen. It's in a green button.
Yeah, I know how to do that, but the option is grayed out for some reason.
Okay, maybe do I have to make you as a host? Let me.
Let me see. Okay. Okay. Yeah, I got it now.
Okay.
1 minute. Okay, sorry.
No problem. You can just start talking something on this, you know.
Yeah, can we discuss it before?
Yeah. So the idea is, so similar to linked list cycle. So we have to keep a slow pointer and fast pointer, and the one difference is we need to keep the entry pointer. Um, so the entry pointer is the one which helps in finding the position. They gave the position, right? Position 1 and position 2 or something like the entry pointer will help you
Okay.
finding that.
Hmm.
1 second.
So you are saying that you will start a pointer which will be a slow and fast pointer,
Yeah,
and then you point it to the head,
yeah,
and then you will start iterating. And when you're iterating, actually you know, the fast pointer will hop for 2 nodes, and the slow pointer will just hop for every node, right?
right. Yeah.
Okay. Yeah, you got it right. Okay, good.
I'll try. Were everyone able to see the screen?
Yeah. I'm able to see it.
Okay. So this is where so at the beginning, all the slow pointer and the fast pointer, entry pointer, everything points to the head. The only thing is this fast and slow will get traversed to
Okay.
the whole link list. Um, so this entry pointer is the one which detects the cycle. Um,
Mm-hmm.
okay, so see the fast, like initially the slow pointer starts with uh, next element, but in the fast pointer it starts to next of the next.
Okay.
Okay. So first, initially you are finding out whether the list have a cycle or not. So once you find the cycle, this is where you find the cycle.
Uh-huh.
So you start another loop to figure out the entry point.
Okay. So the entry point. Okay, you are actually setting it to head over there. Yeah.
Right. Yeah.
Uh-huh.
Uh, when you find out the entry point, like so basically when the slow and entry point is not in sync,
Mm-hmm.
that means you have to increment the slow and entry pointer, you have to move on to the next one.
Okay. And so when actually they meet, you just
Then
come out of the
yeah,
loop
come out of
and return that.
and return the entry.
Okay.
If there is no cycle at all, like it will return null. So there are two things. We are doing two things here. So if you don't have this portion of code, right?
Mm-hmm.
If you don't have this portion of code, it will detect the cycle, whether the linked list has cycle or not.
Mm-hmm.
If you have this one, it will find out the position, exact position where it
Where it intersects. Yeah.
yeah, yeah.
Okay.
So we can quickly run this one.
Mm-hmm.
Hello,
Yeah.
I have a question over here. Our entry point is pointing to the first node of the linked list, right?
No, it can point to any node. That is what the problem statement says. See, for the first example, it is pointing to the
But
node.
in the code, we have just initialized it to head, right?
Oh,
In
initially
the code,
to the head. I'll show you.
Yeah.
okay.
You'll have to write the solution, right? Yeah. I think, yeah, you don't have to run it though, but we can just discuss.
Yeah. So initially it starts with head. When you find a cycle, you are incrementing the entry pointer here. So that
Okay.
yeah.
Could you make the code? Could you make the font a little bit bigger?
Sure.
Can we take an example and go through it?
Okay, sure.
Can we take the first example 1 and just run the code?
Yeah, give me 1 minute.
Yeah, that's fine. Yeah, Ravi. Yeah.
Okay, we'll take the first example, right? So.
Yeah.
So the first one, right? So here, slow points to 3, fast points to 3, entry points to 3. Now, when it goes here, we are initially checking for the null condition, right? So now slow points to 2, fast points to 0. It comes here. This is not same. The loop continues. So again, it goes to like slow to 0, fast to. So anyone get? Yeah, anyone tell me what is fast points to now? So the fast points to what now?
2. Because
It
minus
already
Fast
yeah,
was 0.
yeah, that's right.
2.
Still loop is not detected, right? So it goes again to 4. Fast points to -4, right? Now we find out this list have a loop cycle. Okay, so we go inside. Now slow is -4, entry is 3, right? Which is not equal. Then slow points to 2, entry points to 2.
Yeah.
So you return the 2. Yeah, that's the result. So you have to find out the tail connects to the node 1. Yeah.
Yeah, whatever the node it has supposed to connect. Yeah. Yeah, in this case, it is the position 1. Yeah.
Hey, could you try the example with only 2 nodes and there's no cycle?
Okay.
So 1 point to 2, but there's no cycle.
Okay.
Yeah, just second one, just take without a cycle. Just 1 and 2.
1. Yeah. So initially 1. Oh, so here.
So this is the second thing, what you're just doing it for checking the condition going in the while loop, right?
Right. Yeah.
Okay, so that will be null there.
Yeah. So it is like it goes to null directly.
Yeah.
Is that because I say, could it be could it have like no pointer exception? Because what if fast is no?
That's what I'm checking here.
Yeah, I know, but let's say if fast is no, like we only check a fast next and fast next, right? But
So the fast next is and slow next is like same one. In the first iteration, fast next and slow next is same. It points to the same pointer. So if there is any null pointer, it will get like ignored over here.
So if fast equal no, then
fast equal null is checking at the top. If you look at the head equal to null or head next equal to null.
Right.
No, I mean when it's not at the beginning, but when we move fast and slow in the loop, right? At one point, fast would be point wouldn't it? Like on line 20, I think line 21, could possibly fast is point
So this is a while loop,
No,
right? So in this
it will not enter in the loop if
Right.
fast. It will be null. Yeah.
So if you
He's
see this while
actually
loop,
saying, no, he's correct. The second line after this while loop, we are changing the fast pointer over here, right?
Yes.
So this now may be a null. Like fast colon next, fast dot next can be a null, right?
No,
After
that's not possible. If you see the while loop condition, so it's already checking that fast next should not
Oh,
be null.
yeah. Okay, got it.
Okay.
yeah. Are we clear? Like any questions?
So can we discuss here that why this approach will work?
Yeah, that's very tricky.
Yeah, and also like both, as in finding the cycle as well as why we increment only one. Like slow is going at a rate of 1 and fast is going at a rate of 2. Why not fast is going at a rate of 3 and slow is going some abrupt rate? Then can this also work at that on those circumstances as well?
I never tried that, but we can try. I my guess is like you can do that with 3 pointer. You can jump your fast pointer to 3 nodes, but I don't think.
Yeah, the 3-pointer is a very interesting scenario, but I think it is out of the scope for this problem. So I would just say like just discuss why this loop actually works. Yeah, this is what my opinion. But I'm free if
Sure.
you guys want to go. Yeah.
Yeah, sure.
We'll quickly run this one. Let's see.
So the way I look at it says like if there is something like this loop, the example first, and if we have the first node, like if we say this before the intersection, if we consider that as an F position, and the place where it meets, we call it as an A, and then we equate both of them, like the distance of the fast pointer equal to twice the distance of the slow pointer, then I think we should be able to get into that scenario where actually it says that the initial portion, that is the heading portion, that is the F, is equal to the remaining portion where it meets in the cycle.
Could we draw it?
Yeah, actually
Yes,
he's explaining it.
Yeah, Santosh, you want to take the screen?
Okay.
Yeah.
Okay, so let me see where I can whiteboard. Okay, so okay, this one, and then you have the cycle. Okay, I'm so bad at drawing here. And if we say this F, right? Okay, and if it meets over here, we call the whole of this as something like an A, and the rest of this maybe just B. And okay, let me see if I go write the text. I don't know how to make this over. Okay.
Try drawing like try to draw in a small circle, like so that you can use the full screen.
I'm actually trying to write a text now.
Oh, okay.
So, okay, yeah. So what I'm saying is, now if we say the distance traveled by the fast pointer, okay, is equal to twice the distance traveled by the slow pointer, right? Distance traveled by the slow pointer, okay, slow pointer. And distance traveled by the fast pointer. And if we see the distance traveled by the slow pointer will be f plus a, okay, and the distance traveled by the fast pointer will be f plus, like a, a,
A plus B.
yeah, a plus, it won't be a plus b, I think it will
2A,
be
2A, sorry. 2A.
and c, because the c is the circle, and then plus a, right? So it will be, as you said, it will be f2a if we evaluate this further. So it will be 2f plus a. Sorry,
what is n?
I'll explain that. N is the number of cycles if it keeps going in the cycle, right? So if it is like 2a plus nc. So if this f is too long, then there will be many cycles going inside, right? So that is the nc and then plus a. So if it is 2a, then it evaluates to like f is equal to nc minus a.
But what is
So
c? I got lost right there.
okay, the c will be a plus b actually. So if it is more number of cycles in it, so n will be more than 1. So in that case, so nc, if it is only one cycle, so the c will evaluate to something like f is equal to 1 into a plus b minus a, and then it will be b, right? So that is what the proof would be. So is this bit clear, or
So
Or
we are starting from the midpoint entry, right? Entry is equal to the slow pointer, right? And then we are going one by one. So in the equation f equal to 1, a plus b minus a. So f is the distance before the loop, right?
yeah, so this is the f, the start from the starting point before the entering into the circle, before the entry in the circle, yeah. So that is f. So the
So
slow pointer will travel from here f to a. So the fast pointer, if the f is too big, so the fast pointer may have made many circles. So therefore the n is the number of cycles, and c is actually a plus b.
so why you actually in the equation you on the right hand side you have done that f plus a plus nc plus a.
Yeah, so f plus a will always be there, right?
Yep.
So then there will be more circles, and then it will be meeting at the a, because they are both meeting at the a point.
Okay, got it.
So that is what actually I'm considered it for.
so are you trying to say on the first cycle itself, the slow and the fast will meet?
It depends. It might meet also. Okay, I
But
don't think so. It will meet, but at
yep.
least for the first point, it will go through, and then they will meet.
So
Because
why
if
didn't
they
you
meet, then
consider in your proof that part?
which one?
That the slow cycle. So it is possible that the slow cycle will also complete one circle before meeting the fast pointer, right? It's possible,
Yep, that's possible.
right?
So
So
in that
if
case, the n will be 0 then, right?
no. What I'm trying to say,
Huh?
let's say the slow pointer. Okay, let's talk about the slow pointer. Let's say slow pointer started from f, right?
Mm-hmm.
So slow pointer traveled f distance, then a plus b distance, then a distance. Okay.
Mm-hmm.
Whereas the fast pointer travels f distance, then a plus b, a plus b, a plus b, and then a. Right?
Mm-hmm.
It's possible, right?
Yeah.
So why didn't you consider that part in your proof?
So
In the proof, it's considered only.
so that is what I'm considering. Like NC itself is saying that NC means is the number of these cycles A plus B. C is A plus B actually. Oh, sorry.
Yeah, I understand, but you're considering only for the fast pointer, not for the slow pointer.
Yeah. What he
Okay,
meant
so
that
but okay, I'm taking the simple formula. Okay, so that might be the case, but then in this case, the whole thing on the fast pointer side also will change, right? So if you're considering that way,
no, the fast you already consider that it will complete n cycle before they meet. So the same for the slow. It may complete x cycle before they meet.
okay. So anyone has any other suggestion in that? So does someone want to share their screen, draw it? So this is what I
think
understood. Yeah,
I
maybe
think your
someone
proof
has more.
sorry, I think your proof is almost pretty good. And what Gaurav was saying, that instead of calling 2 into f plus a, you could say like f plus some m into c plus a.
Okay. So
So
here also
eventually,
you just add f plus. Okay, I'm
yeah,
not
some
able to do
cycle
that.
for slow guy also.
Okay,
Yeah,
and then put
and
that
I
on the
think
fast side
eventually it
also.
will become an integer. Yeah.
Okay.
Yeah, so eventually you will derive the same thing, because now just n and m will give you a different number basically.
Okay. So a
Exactly.
bit clear. Yeah. Okay. No problem. That's good.
Yeah, by the way, thanks for the proof. It's a pretty nice, you draw it pretty well.
Yeah. This was my understanding. Yeah. It's good. You guys also helped me in understanding it. Yeah. So shall we move on to the next problem, or do we want does anyone has any questions in this one?
I have a question. So
Yeah.
normally, like it's not to just test it. It's more like in interviews they ask if there are more than one cycle in the linked list, then will this approach work? So right now, whatever examples we took to solve the problem, we had just one cycle.
No, that is what these guys were saying now, right? There will be more cycles. If there is more cycles, then how do we prove that? And he was saying, Roger also said that I should add year in the distance for slow pointer. I should add something like a plus MC, and then also do the similar thing at the fast pointer side. And
Okay.
then,
And the same solution will work?
yeah, it has to
Okay.
work. Yeah.
Are you talking about like the two cycles, as in?
In the example itself.
Okay. Okay.
Is it clear or?
Yeah, actually, I have one more question. Like we use 3-pointer, right? Fast, slow, and entry. So instead of that, we can optimize with the 2-pointer, like slow and fast. We just change the. We will keep the fast pointer at the same place, and we again slow pointer as the starting of the list.
Yeah, you can do that optimization. Yeah, that's a good thing to do. Yeah, sure.
But it doesn't add any runtime benefit.
Absolutely, yeah. But she's saying that if you want to do some optimizations, and sometimes they ask in interviews if we can do something more, then it's always good to say, yeah.
That we can do, because you already find out the initial cycle, so that pointer is not needed
Yeah,
anymore.
yeah, it's not useful, so you can use it somewhere. Okay. Any more or any more questions? Okay, if not, then I will just move on to the next one. There is something for which, okay. So this question, the delete operations for toString. So in this, the delete operation, it says like if there are two words, the word 1 and word 2, we need to find the minimum number of steps required to make word 1 to word 2. It should be same. Where in each step you can delete one character in either string. So guys, can you see my screen? The third problem?
No.
Oh, sorry. Okay. Now is it visible?
Yeah.
Okay, I'm sorry about that. So this the third problem, delete operations for two strings. Uh, it says that we have given two words, word 1 and word 2. Find the minimum number of steps required to make word 1 the same as word 2. And in each step, you can delete one character. So for the first example, if you have something like SCA is the word 1, and if you have EAT as the word 2, so we can make both the words same. Like I can remove S from the first word, it will be EA, and in the second word, I can move the last alphabet and make it EA. So both of them are same. So what I did here was I deleted the first alphabet from the first word and the last alphabet from the second word, and therefore my answer says gives an output of 2. So I deleted 2 alphabets, therefore the output is 2. Okay, so and it says the length of given words won't exceed more than 500, and all the characters in the given words can only be lowercase. Okay, so this is what the problem statement is. Uh, do you get what the problem statement says?
Yeah.
Okay, so any approaches anyone has?
We can sort the string, both word 1 and word 2. Then do a string compare and remove the words which are string str and find out the index which are matching.
Oh, okay, so you're saying do a sort of okay, in this first example, if I do a sort, it will be A, E, S, and then for the second one, it will be A, E, T, okay, and then you are saying then have two pointers, means starting for the both of the words.
Yeah.
And then compare if they are not the same, then keep on proceeding. Is that what you're saying?
Yeah, just compare. I assume both are like in same length. That's not the.
I don't think so. They might be of different lengths also.
Oh, okay. Or maybe this one will be like brute force. Basically, you compare word by word. If it is not matching, then remove the or just increase the counter for the output.
Okay, so you are saying set an index for the first word,
yeah,
as well as the second word, and compare both the starting alphabets. If either of them is not there, just
let's call word 1 as. Yeah, right. Yeah, you're right.
And then here they both match. Therefore, we just move from A to A, both of them. Then move E to E, and then S and T both are not matching. So one will be like move the word 1's index and say incremented the counter by 1, and then come here. Yeah, that might also work as a brute force. I'm not sure. I didn't try it that way, but that's a good thing you brought up.
If you change the input to A, E, S, and T, let's
Here, the
yeah,
first one.
yeah.
Okay.
Add a T here. So now you have to make a decision at the third pointer that whether you want to remove an S or you want to remove a T.
Oh, okay. So that's a good catch. Yeah.
Okay, it will fail. Okay.
Okay. No problem. That's a good one. Yeah. Okay. So the sorting might not work. So any other solutions?
Can we use the map to keep the count? Like how many times as occurred in a first string and how many times it has occurred in a second string. If it has not occurred in a second string, we will increase our count.
Okay, that's good. Interesting one. So you are saying we have a map, okay, map for the first one like MP, and then whatever the counts are for each one, I just keep it here. So if it is S, I'm just taking the first example, E and then A, and then I have another map. So keep it.
Or maybe like we can go through even say like optimization may be possible. I'm not very sure. In the like second time we go through like through the same map and see the total number of counts. Like we found E, so decrement the count of E now in the first map.
Okay.
And yeah,
so I
and
just
if it reach,
decrement.
yeah,
Okay.
if it reached the 0, just remove it. A again we found decrement it, we found it, so 0. T we do not found, so add it in a second map. Now the size of both map is the
1 1, and then just add them, and then okay.
Yes.
Okay. But then how do we iterate through both maps?
Now we can just take the size, right? Or yeah, we need to do addition maybe, like how many times S occurred. So if S is still 2, then that 2 plus 1. Like if T has occurred once. So yeah, we have to do the addition.
Okay.
What about the input ABC and ACB?
Okay. ABC
and ACB.
ACB. So you are saying with the map approach?
Yeah. What should be the answer?
So it will be 0, right? Because
ACB.
But in the map it might be stored as a ordered one,
that's
right?
true. That's true. That's true. But should the answer be 0 or not?
Yeah, it should be 0. Oh, okay. Oh, I'm so sorry. No, it should not be 0 yet. Yeah, you're right.
Okay, it should not
So
be 0.
because okay, so because you're actually not going to change the word ordering.
Yeah. So what I'm trying to say from both my anti-examples is the ordering matters.
Yeah. Okay. So the sorting as well as the map won't work. So we'll have to go through the LCS way. We'll have to find a common subsequence. Yeah.
Before that, I wanted to add actually, this can also be solved. I think with recursion.
Yeah, sure.
For example, let's consider the same example. It's a SEA and EAT, right? So over here, we will take a decision whether if both the characters are same, right? So for example, S and E are same. So if they are not same, so it means either we have to remove the S or we have to remove the E, right? And because we have to find the minimum, so we can say that 1 plus, okay, because we have to remove either S or E, right?
Yeah.
So, and then minimum, let's say some min function.
Okay.
Yeah, 1 plus min.
1 plus min of okay.
EA.
Okay, so we'll just
because
say
I removed
1.
S. Yes, assume, yeah, 1 plus EA.
Okay, EA,
comma, or AT, right?
Okay, so
yeah, and I keep the EA and EAT. Yeah.
Okay, so you're saying like, so you're trying to use the recursion way of finding it.
Yep.
Okay, and then you keep on doing it for the others, right? Okay.
Yep.
But again, this approach may not work. Like I'm not very sure. I'm just asking, will it work if we have like at the start say P? Instead of EAT, we have PAT. So actually, we should do both S plus P because there are two different characters.
Oh no. What? Okay, I think what I was trying to say is that we have to recursively call this min distance function, right?
Yes.
In this case, in the first case, the strings become EA and EAT. So word1 will become EA and word2 will remain the EAT. On the second, On the
Yeah.
Yeah,
second
so
thing,
it should be minimum of EA and EAT.
EAT,
Right?
yeah, yeah.
yeah,
Okay.
exactly.
Yeah.
Or
Sorry about that.
or
Mm-hmm.
like, because min takes two methods, right?
Uh-huh.
And these are the two parameters of the min distance itself. Did you get that?
Okay.
I know, because we are calling recursion, right?
Yeah. So you are saying once you remove S from the year,
Yeah,
and the second time actually you want to have that S, right?
yeah.
Yes, SEA and
Yeah.
SEA
AT.
and then
So
80.
80, yeah. So yeah, it should not be this year, and then 8 EAT, right? So it will be the same year.
No, 80.
No, 80. So now this time you remove
Yeah.
the first character.
Okay. So it.
And this is at the method level, not like this. So what I'm
I
trying to
got it.
say,
Yeah. So you'll have a
or
method here.
yeah,
Mm-hmm.
or if the first character of the string are same, right?
Mm-hmm.
It typically means that we don't have to delete, correct?
Mm-hmm.
So in that case, we will remove S and E both. So we will see for EA and AT.
Yeah. So yeah, if it's just a recursion, it will give a TLE, but then we'll have to put memoization, like you'll have that top-down approach, right?
Yeah, that's
Yeah.
a separate thing, but yeah,
Yeah.
this can be the very, very basic approach.
Absolutely, yeah. I think this should work. And do you want to go for it? Do you want to try it? Okay, I think I'll just write the solutions, something like this over here. Maybe you can help me, and then we can actually go for the LCS way also, if time permits. So, well, okay, then let me first write the function here. Okay, say if I say, because we are just returning the integer, I will say, okay, what your function name will be, helper here, and then we have the string one. Okay, I'm just, and the string two. Okay, this function should be on the top. Okay, and then you want me to start. Okay, so this will be string one s1 and string s2, and then you have an int idx1, right, and int idx2. Okay, and then if you say if this is a recursion, plain recursion, I would say if, okay, idx1 equals s1 dot size, okay, or idx2 is equal to s2 dot size, all right, then I would just return 0, or else if s1 of idx1, sorry, s1 of idx1 is equal to s2 of idx2, then I would say return, okay, I'm sorry, yeah, so you want to go ahead in this, what I have to do?
So you will return, good. Keep
Return
on return helper, and then you're writing in C. Yeah, so you have to write the substring of.
I'll just, because I'm just using the index, right?
That's fine. Yeah, that's
and then if else we can say, right, you know, like
return min.
It should be min or max. I'm okay, no
Min,
problem.
because you have to find minimum length, right?
Okay, so S1 and then S2.
Yeah.
And here you will say first will be IDX1, just an IDX2 plus 1 something.
That's true, comma.
And then helper will be S1, S2, and it will be IDX1 plus 1 and just IDX2. Is this correct?
Yes, looks correct to me.
Okay. Okay. So, guys, did you follow this? What he is trying to say?
Yep.
Okay. And I just need to call this here in the one, right? You have to say. Now, this guy is actually going to give us only, okay, it will give us the complete function. So I just say return helper, right?
Yep.
S1, S2,
There's
and
no S1,
0.
S2, word 1, word 2.
Oh, sorry, yeah. Okay, word 1 and word 2. Okay, and then we just give the start index here. Okay, I think this should work. Maybe small things here and there,
So you
but on
just
broad scale.
calculated longest, common subsequence so far, but the problem will need a little bit tweak. Based on this, you can
Absolutely.
figure out the actual solution, right?
Right.
You can't just return here. Is
So
that
actually, see, Roger, when you come to LCS, we'll have to find the LCS, and then you'll have to get the word sizes and add the word sizes, and then subtract 2 times the LCS. But in
also
this case, he's saying that you're finding the minimum already. So it might be the direct, we are trying to get what the things are
all
being
right?
deleted.
Yeah,
Yeah, that is what I understand.
I didn't look at this. I was away. So okay, if that was
No,
taken
no.
care, yeah,
Yeah.
just want to
Yeah,
mention.
just want to add one other thing. At line number 4, right,
Mm-hmm.
where if idx equal to this s1 dot size, I think this is wrong. The reason is, let's consider the case, right?
Mm-hmm.
So let's say there is an empty string,
Mm-hmm.
and then there is some string abc, right?
Mm-hmm.
So in that case, we are currently returning 0,
Okay.
but actually we should delete all the characters. Am I right?
Right. So in this case, we can actually do that if
No,
earlier before we
that's
do that
fine.
word
But
function.
during recursion itself, we can land up into that situation, right? That's what you are checking actually. So
So
this
you are
should,
saying instead of returning 0, you just return the whatever the remaining size, right?
yes. So whichever
Okay.
is not. So basically, if both the sizes are, if both the strings are empty, so in this case,
Mm-hmm.
idx1 equal to s1 dot size and idx x2 equal to s2 dot size. In that case, we will return 0.
Mm-hmm.
Otherwise, we will return whichever is not empty,
Okay.
the size.
Yeah, I think that might be a case to consider as a corner case. Yeah. No,
Yeah.
not a corner case. It's the main case. Yeah, in the base case, right? Yeah.
Or otherwise, on a line number 10, we have to do 1 plus, like 1 plus minimum of this.
Yeah,
Otherwise,
I
this
think
function will always return 0.
Good catch. Good catch.
yeah.
Thank you. Yeah,
That's also important. Yeah.
absolutely.
Otherwise, we will always get 0.
Yes. Thank you. Okay, so is this clear? And there is an LCS way also. Do you want to go through that, or this is okay? Because
I think we can optimize it further.
yeah, we can optimize by putting a memoization, right?
We can do the memoization. That's
Yeah.
true.
Or else, do you have something else when you said optimization?
Usually, like this recursion, then memoization, and then you can also go the bottoms up approach, right?
Yeah, the bottom up approach. So, do we want to go the bottom up approach?
I'm fine with this.
Okay. So let us ask other folks, is it okay, or do we want to go through the bottom up approach? I think we discussed the bottom up approach last time. It only says that when we have that DP array, 2-dimensional array, we just have to compare if both of the alphabets are same. In that case, we have to go to the diagonal one and then add 1 to it, or else if they are not same, we just have to get the maximum of the left side or the top side of the particular index in the 2D array. So that is also very simple. First find an LCS, and then when you find an LCS, you get the number of counts in it. Then you just have to subtract with the word size of word 1 and then the word size of word 2, subtract with the 2 times LCS.
Yeah.
So is this okay, or do you want to go with that? Yeah, Raj, sorry, go ahead.
No, I was just saying so I think Gaurav posted on the link somewhere that he will discuss longest common subsequence when he will do the DP session.
Okay.
It could happen soon. So yeah, if you guys want to defer it for then, it should be okay. Like we will cover that anyway.
No problem.
Yeah.
I think he explained it last time also. That was pretty clear. Yeah.
Yeah.
Yes. Does anyone have any questions? Okay, looks everything is good. So I will stop the recording. Is it okay, Roger?
Yeah, I mean, I'm fine. Anybody has any last minute question, or we can just stop the recording and then we can hang out a little bit if required. Means yes.
Yeah, sure.
All right. First of all, thank you very much, Santosh.
Oh, thank you. No problem.
Yeah. And the other